this video, we're going to go through the column base plate calculation included in your TEDS trial. Note that this module does include both the base plate and anchor bolts. We do offer a calculation that only checks the anchor bolts, but this is reviewed in a separate video. To begin any of our TEDS calculations, simply click on the New button and navigate to the calculation you would like to run. Once you have located the calculation, you can easily just double-click on it or select the Calculate button in the lower right-hand corner to begin the calculation. Don't forget to check out the notes we have included for each module outlining the scope, which codes were used to create the calculation, and any assumptions and limitations that have been made or are present. Once you start the module, your output page will start in the background, then you will be presented with a series of interfaces. Each one of these works like a book, top to bottom and left to right. You will also notice a parametric sketch on the top of the interface that will continue to update as you move through the calculation. So starting with the geometry, let's start with the column section size of 12 by 35. You can select Size Base Plate to set the initial dimensions of the base plate to be 3 inches from each side of the column you've selected, rounded up to the nearest inch to accommodate the anchor bolts, or you can choose to skip this step and enter the size yourself. Next, select which axis you would like your moment to be applied to. Even though the base plate now has a preliminary size of 19 inches by 13 inches based on the column section, we're going to modify this to be a more common size. You can change the dimensions by using the arrows to the right or by simply typing in the input box. Moving along to the weld details, you can select a fillet weld or a complete joint penetration groove weld. Sticking with the more common fillet weld, you can then enter in an electrode classification and a flange and web weld length. Lastly, the foundation details will need to be entered. We will assume we are working with a 4 foot by 4 foot spread footing that is 2 foot thick. Notice that you can simply type in any unit into the input field and it will be converted to the specific unit being required in the calculation. This can be very handy if you need to switch back and forth between metric and imperial. You will notice that our sketch is updated with all of the information we have just input. You can pan around and zoom in and out of the sketch using the scroll wheel on your mouse. Next are the design forces. Note that these should be ultimate loads that you may have calculated using one of our other calculations, a set of hand calculations, or from another analysis tool. Notice once you enter in a shear force, you will then have to select your shear transfer type: friction, bolt shear, shear lug, or base plate embedment. For this example, we are going to use a shear lug. In the Material Details menu, we will leave these as the default values. However, if you are not sure where these values came from or what the appropriate inputs include, you can simply hover over the information bubble to get the code excerpt. Now on to the anchor bolt details. First, you can select from a variety of cast-in-place options like headed end, hooked end, and headed stud. But don't miss the fact that you can also select proprietary bolts. If this option is selected, you can then go into the bolt details, select which type of post-installed anchorage you would like to use, then enter in all the variables associated with this bolt. These come from the ICC reports and should be published by any bolt manufacturer. For this example though, we are going to stick with 4 1 1/8 inch diameter headed end bolts with a 16 by 6 spacing, embedded 10 inches, and with a head bearing area of 1 inch squared. Next, we will need to enter in the information regarding our shear transfer mechanism. We're going to assume the length of the lug runs the entire width of the plate and is embedded 4 inches with 0 eccentricity. We will leave the thickness of the lug to be 1 inch, the weld size is 3/8, and the grout pad thickness to be 1 inch. Finally, you will need to designate your design options. Here we will stick with LRFD and all of the latest design codes, but we'll change the supplementary reinforcement factor to 1.2 since we will likely be using a number 4 bar or greater in the footing between the anchor and the edge. Notice you have the option to include a built-up grout pad, whether or not the bolt has a constant stiffness over the full length of the embedded section, and if you only want to see the output for the most critical shear breakout. This calculation will default to the US steel sections for the column size. However, if you happen to be working with a foreign section, or possibly even a historical section, you would need to set this design option first, then go back and select the appropriate column size. The results are organized into 3 sections: plate thickness, welds, and shear transfer. Simply use the gray selection button at the top of the results view to toggle between the 3. However, if the combination of your axial load and moment throws the bolts into tension, a 4th section will be added to go through the Appendix D checks as well. Lastly, you need to select your output options. Here you have the ability to change the title of your calculation to something more meaningful for your project. You also have the option to select a full output or a summary of this calculation. Depending on your region and who will ultimately be reviewing these calculations, this may vary. However, it is very simple to switch back and forth as needed. You can also select which graphics you like to include within the output. Once you select Finish, you will get a line-by-line output going through each of the calculations included in the design. Every variable will be defined, each equation written out, and every code reference provided. This eliminates that black box feel entirely. Now, if something needs to be changed within the calculation, simply click on the Calculate button and the same series of interfaces will appear. Make whatever changes are necessary to update your calculation and hit Finish. The output will automatically be updated. Be sure to check out the other TEDS trial videos that go through each of the other included calculations, as well as how to customize them using TEDS for Word.